Hi, Assalamualaikum everyone. We are from Group 8 from Class M4 CS241 for M1. We would like to present our answers on Assessment 2 for course STA568 Mathematical Statistic 2 for question 8. Before going further, I would like to introduce our team members. My name is Muhamad Afiq bin KAMASAHPIHI, and as you can see, my team member is Muhammad ALIASSAFFARUL bin ISMAIL. Without further ado, let us take a look at the question. Question 8. Let x1, x2 on the left hand be random sample of size n from a normal distribution with mean 0 and variance theta plus 1. A. Find the distribution of a new random variable y equal to xi squared using the moment generating function tab. Before we start answering the question, first we need to take out all the important information from the question. It is given that xi distributed normally with mean 0 and variance theta plus 1. Then we find the distribution function of x, fx equal to 1 over set sigma squared 2 pi times exponent to the power of negative 1 over 2 sigma squared times x minus mu squared. Now we can find the moment generating function of y. The moment of y is equal to the expected of exponent to the power of ty. Then we substitute y equal to x squared into the equation. In order to find the expected value of exponent tx squared, we need to integrate the exponent of tx squared times fx dx from negative infinity to infinity. After substitute the fx into the equation, we then substitute mu equal to 0 and sigma squared equal to theta plus 1 as given in the equation. Then we can take all of the constant out of the integrals to make it look simpler and easier. Then, as you can see, I combine both exponent together, so then we can calculate it easier. How do I combine it? Do you know that if you have two terms with the same base, you can put the base together and just add both powers together. As you can see, I put over that t minus 1 over 2 theta plus 1. That is my answer after I factorizing the x squared. So we can look at the integrals and we can know what function is it. Now, if you look at the list of distribution function, we can see that the only distribution that is having domain from negative infinity to infinity are normal distribution and standard normal distribution. But if you look further at the function right now, the only distribution function between these two distribution that having sigma squared at the exponent is normal distribution function. So in order to get rid of the integrals, we need to get the normal distribution function here. So that's why I put the 2 theta plus 1 t minus 1 down to the of the fraction, so that it will look more likely as the normal distribution function. Then I factorize negative 2 out of it. Now, to make it looks more likely as the normal distribution function, we need to put 1 over set sigma squared 2 pi at the front of the exponent. So that's why I put 1 over set theta plus 1 2 pi over 1 minus 2 theta plus 1 t at the front of the exponent. But in order to put it there, we need to put something reciprocal to it at the front of the integrals. So then if we multiply both of it together, we will get 1. So that's why I put set theta plus 1 2 pi over 1 minus 2 theta plus 1 t at the front of the integrals. Now, as you can see, the integrals already looks more likely as the normal distribution function. So then we can let all of it equal to 1 because the total of the probability is equal to 1. Then we left with the constant at the front of the integrals just now. We can simplify it and we left with 1 over set 1 minus 2 theta plus 1 t, and we can bring the function up. So our answer will be 1 minus 2 theta plus 1 t to the power of negative 1 over 2. As you can see, the moment of y just now are most likely as the moment generating function of gamma distribution, which is 1 minus theta t to the power of negative alpha. So that's why we can conclude that y is distributed with gamma distribution with alpha 1 over 2 and theta equal to 2 theta plus 1. Now, let us take a look at the next question, question 8b. Use the result in A to find the distribution of a new random variable W equal to summation of xi squared from 1 to n over theta plus 1. Hence, state the distribution of W and its corresponding parameter. Now let us answer this question together. This question almost looks like the first question just now because both of them are using the moment generating function techniques, but there is a little difference in it. We will take a look at it. So the moment generating function of W is equal to the expected of exponent to the power of TW. As usual, we substitute the W with the formula given in the question. So we substitute W equal to the summation of xi squared from 1 to n over theta plus 1. Now, we break the summation one by one. So we will get the exponent, the expected of exponent to the power of t over theta plus 1 times x1 squared plus x2 squared and so on until xn squared. From here, we're using the same theorem that I used before in question A, which if we have two different terms with the same base, when we multiplying both of the terms, we can just add the powers together. But this is the other way around, which we have the summation at the powers, so that we can divide them into different terms by multiplying all of the terms. So that's why I get the answer here, which is the expected of exponent to the power of t over theta plus 1 x1 squared and so on, just changing the x1 with another x. Okay, then as we can see here, the expected of exponent t over theta plus 1 x squared looks most likely like the moment of y that we did in A, but it is having different terms of t. So that's why we can write it down here as moment of y with term of t over theta plus 1 for all of the terms just now. As usual, make sure to multiply all of it. As I said just now, if we have multiple terms with the same base and we multiply all of it, we just need to add all of the powers together. So if I have 4 times 4, I will get 4 squared. As easy as that. So if we have the n amount of term and I multiply all of it, we will get the power of n. So that's why I get over here, the answer is the moment of y with term t over theta plus 1 to the power of n. This looks familiar to you. So now we just need to substitute the moment of y. So the moment of y is 1 minus 2 theta plus 1 t to the power of negative 1 over 2. We substitute t equal to t over theta plus 1. So we simplify the answer, we will get 1 minus 2t minus n to the power of negative n over 2. As you can see here, the moment here looks most likely like a chi-squared distribution. For chi-squared distribution, it is 1 minus 2t to the power of negative r over 2, which r is the degree of freedom of the function. So we can conclude that W is distributed with chi-squared distribution with degree of freedom n.
For question C, they want us to construct a 1 minus alpha 100% confident interval for theta based on our answer in B. So first, we need to write probability statement of W, which is bounded by chi-square distribution, which we already defined in question B. After that, we need to sub our W with our test statistic that is given in the question, which is sum of xi squared over theta plus 1. To get theta, we need to invert the inequality to both sides of the equation so that it will leave us with only theta plus 1 in the middle. To get only theta in the middle, we need to subtract both sides of the equation with 1 so that it will leave us with theta in the middle. Therefore, that is our 1 minus alpha 100% confident interval. For question D, it is said that if sum of xi squared is equal to 1000, n is equal to 10 and alpha equal to 0.05, find the interval estimate for theta. From our answer in C, we need to sub all the information given to us, which is sum of xi squared is equal to 1000 alpha is equal to 0.05 and our n is equal to 10. After that, we need to look up for our critical value in chi-square table, which is for the upper tail we will get 20.483 and for the lower tail we will get 3.247. After that, we need to simplify that and we will get 47.8210 and 306.976 for our final answer.